So a little disjointed this morning, bear with me. I can promise you two things. One, we're gonna have some fun today, be able to go through as many different materials and pieces and parts as possible. Second thing is, before you leave today, or hopefully by the time you get home tomorrow, Paul will actually email out a PowerPoint so everybody has it, okay? That way you don't have to worry about as much materials and then have an opportunity to get everything printed out because it's 20 slides deep. But I want to make sure that you all do not worry that you're going to have this on hand. So definitely some key points, and we'll have some questions, I'm sure, throughout the day for materials and different techniques. But specifically, a kind of how-to guide and things to think about when you're building these devices, you'll be good to go. So you'll get that before the end of the weekend. All right. So first thing is, my name is Conen Morgan. Conen, C-O-N-E-N. Of course, my entire life, everybody has assimilated me to the barbarian or the late night talk show guy, which is fine. I blame my mother for all of that. It's a good thing. But separately, I am from North Carolina. I know many people normally ask me, what year am I in school? Have I graduated from college yet? The answer is yes. I went to NC State University. I have a degree in computer science. This is actually going into my 25th year of Olympiad. Wow. So I did 7 as a student, and the rest of the time as an actual adult. I've been to 8 nationals now. I competed, as many of you students have been. I have been co-event leaders with Manly Midget, who's in another room doing another event. We would normally focus on Mission Possible. I have actually helped coach the team, led different events at states and nationals, and done the whole gambit of things. So I've seen the rules change. I've been on the national committees for all that. I've seen everything change over the years. And the Hovercraft being a new event, it's gonna have its nuances. And I can go into it right now. There's a rule clarification we'll probably go over at the very beginning. But it's stuff, things that are tried and true always stand the test of time. Bridges and towers, easy. You don't have to worry about it. But there are different things that we're trying to include new sciences. It just takes a little time to get the rules and different things set down. So don't feel bad. I'm going to tell you, I don't have all the answers. I have some of them, but we'll get through it. And if there's anything that we need to clarify by the end of the day, we'll get it. All right, cool. So Hovercraft, very simple in premise. And the one thing I always will start off with is I am a believer in economics. Science should be fun, but science should be cheap. So there's no need for you to go out and buy a hovercraft kit. I'm going to tell you that now. If you want to, that's great. We're going to talk about those in a second. But you don't have to buy one that's on the market for like $100. You can build all this at home. I can promise you the components that I brought with me today that I was able to build out and get square, I did it for essentially less than $20 when it was all said and done. There's some different parts that I bought extra just to make sure that you all had a good understanding of everything. But you don't have to spend a lot of money for any of our events. And that's the whole point of Science Olympiad is you can learn a lot of science without having to spend a whole lot of money, okay? All right, so we're gonna go over the actual rules like an actual teacher would. You gotta read the rules, you gotta go over all the different specifications. I wanna make sure everybody has an understanding of that. As far as the test is concerned, I know Paul mentioned that earlier, tests are gonna be different per state. So I'm not gonna imagine whatever is gonna come up here for Michigan. Our test in North Carolina is completely different from what you all have. We just do a lot of comparison at the end of the day. I know different states where some of the elite teams will actually go to different invitational tournaments to be able to compete so they can see the other tests, so they have more material to study from. I would just say that the general science that you would have from different wind speeds and different things of the physics and some of the physical science that goes into it, you're gonna see that on a general test. Now, I will say, in terms of test taking, the test is meant to be speed efficient because the graders don't have all day to grade them. So don't expect a long form essay. This is not the SAT2s where you got to write a different composition. It's a situation by which you're going to have multiple choice, fill in the blank, be able to do some calculations. All right? Well, let's get started. First thing is, as they always tell you when you get a competition, you need to wear your goggles, especially true in this one because you never know what's going to fly off. Everything is going to be battery powered within this actual event. So bring your goggles. And then from there, we're going to start being able to do things with the track and the construction. Let's talk about the track first, okay? And the variances between the track and the rules, okay? First, the track's going to be of aluminum beams. If I can grab one of these. So coaches and parents, if you want to buy these, it's extremely cheap to have these studs. They're less than $5 in most hardware places where you can buy these. Very simple. Put them on the floor, put them on the table, doesn't matter. This is aluminum on purpose, so you can't bang them up or break anything. Normally you would get a wooden block. Well, act like this is my wooden block that's gonna be the center of the track. We've got 2 of these beams, obviously to make an actual rail. And I'll use this wall here as some help. Look, I'll put a hole in the center. All right. Again, simple concept. So we're gonna have guardrails on the road. There's a block there to be able to move out of the way so the car can actually start accelerating down the track. Simple premise, okay? The question for you is, the heaviest car moving at the fastest speed wins. That is essentially that portion of the actual event. So heaviest car, fastest speed. Now, it's gotta be wind powered. What was that? I can't hear you.
I heard that we had to match a speed.
You do have to match a speed, and there's a certain distance in track, but you're trying to find out the efficiency of weight versus speed down a track, okay? One of the important things to know about this in terms of the construction is that it tells you that the length of the vehicle must be between 15 to 30 centimeters and cannot exceed 30 centimeters during the run, okay? If this is my vehicle without the battery itself, 15 to 30 centimeters, obviously this isn't going to be, and I'll go ahead and tell you, this is less than 30 centimeters long, okay? But even if I, sans the fan here, if I'm going down a track, let's say I got 25 centimeters and I've already measured, it's like my length of my vehicle's gotta be this long. Guess what? The track has to be center at 25 centimeters, give or take a few, okay? And it's supposed to be 20 centimeters, give or take a few. There's a 0.5 centimeter variance. And that's just based off of human error in terms of the track being laid out, of the actual aluminum frame being bent. So, obviously make sure you measure. Don't build you a 30 by 30 centimeter portion or even a 25 by 25. Make sure it is a rectangle in terms of size, construction, okay? You need to make sure it can fit in between the tracks. People make simple mistakes like that all the time. Guarantee that when you put it down and measure, it's gonna fit in the track. All right? The second part of it is, it goes and tells you, you can use any material to build a device, okay? Now, in Olympiad, whenever you have an ambiguous term, people use that to the nth degree. So when they say any material to build a device, we inherently will actually do mean anything. So anything that you have at home is key. I would not necessarily go out and buy Kevlar or some type of NASCAR aluminum frame. If you want to spend that kind of money, that's fine. It's not needed, not necessary, but you can literally use anything as your base. As far as the battery is concerned, you can't go any higher than a 9-volt battery. For the students in the room, let's talk about some batteries for a little bit and power, okay? I actually brought with me a number of motors that we'll get to in a minute, but I want to show you some variances in terms of the actual battery packs themselves. So, standard AA batteries, 4 to a set. We could go 2 to a set if we want to. You actually have a pack where the front and back of 4. 9-volt battery. I also brought with me, and I'll tell you a little funny story if I can find it. I have to look in my bag here. There it is. So when I was a child, I used to ask my parents, you know, this is a long time ago, JCPenney catalog would come in the mail. It's the holiday season. Your parents are like, what do you want for the holidays? And I said, I want a remote control airplane. So I started at about 4 or 5 years old. I was like, I want a remote control airplane. So every year for about 20 years, I asked for a remote control airplane. Never happened. Mom and dad are like, nope, never gonna happen. So this year, I've been married now for a little less than 2 years, and my wife actually heard me tell this story again and bought me a drone for Christmas. So I was super excited, happy. I got a drone and I went ahead and put it online, and I was like, I finally got my remote control airplane. This is great. And then I actually had to learn about the battery powers that goes with these drones. They're about this small. This is actually a 3.7 volt battery It's 380 millihertz, and it's 25C in terms of charge. Actually, I think that's the actual model number, not the capacity. This will get me 7 minutes of drone time. If this can power a drone, it can power your hovercraft, I promise you, okay? And I'll pass this around in terms of batteries. Now, I've already looked these up. Of course, I had one battery that came with the drone. I'm a big Amazon fan in terms of ordering stuff from Amazon. You can get 6 of these for like less than $25. They come in packs. So if you want to be able to have some battery power portions in that, and then also strip these down so you actually use them, you can go with them that way, and we'll pass them around.
Can we use an RC battery?
You can use some RC batteries as long as they don't exceed 9 volts.
As long as they say below 9 volts on the back.
Correct.
But they can be overcharged.
Yes.
Are they actually going to measure the circuit, or are they just gonna
Yes, there will be a voltmeter in place at the actual day of competition, and there's a reason for that. Since you asked that question, so he asked, are they going to measure the voltage? Let's go ahead and jump ahead to that particular conversation. In the rules, it specifically states that you cannot exceed 9 volts, okay? It also says you can use power in terms of voltage in series. Let me make sure I said this right, because I'm gonna screw this up, and I did last week when I was teaching it. It can go in, and this is 4H on the rules. Commercial batteries not exceeding 9 volts as labeled may be used to energize the motor on the vehicle. Multiple batteries may be connected together as long as the expected voltage at any point does not exceed 9 volts as calculated by the labels. The vehicles must not have any other energy source.
See, that's why I asked. It says calculated by labels. That's why I'm trying to-
Correct. So, first thing is, you technically can do this in parallel, but you can't do it in series, okay? Now, for those who hadn't gone through the actual science of learning about power and how it works, a battery in series, you're just stringing them together, okay? It's like Christmas tree lights, just stringing them together. Parallels means 2 actions going on at the same time. When you actually do this in terms of connecting your powers, and we'll use a 9-volt battery, for example, there's a plus lead and a minus lead in terms of the top, okay? If you do them in series, you're you're actually doing the exact same negative endings or positive endings. So all your actual wiring will be red to red to red and black to black to black, all the way down. If you're gonna do them in parallel, you will alternate wiring to be able to put it together. Now, to further answer his question, what was that?
You want to swap that.
I said it backwards.
Red.
Yes. Yes, I'm sorry. Red to red to red parallel, and then alternating would be in series. Now, to answer his question, at no point in time should we be able to take a voltmeter out and measure more than 9 volts, okay? You can actually wire up as many as these in terms of the double A's. These are 1.5 a piece, 1.5 volts a piece in terms of double A's, okay? You can wire these up to be able to have as many of these as possible, but it can't exceed this. Now, anybody want to take a guess how you can get a higher capacity of battery power without exceeding the voltage?
Shoulder wires.
What was that?
Shoulder wires.
Shorter wires?
Yeah.
Not so much. Anybody else?
You can alternate between the 2 different sets of batteries.
You can alternate between 2 sets of batteries, yes. Yes, there is some, but you're not gonna get more capacity. You can use 2 different sets of power sources. So you can distribute to get over that 9 volts. Anybody else? All right, so you could, the rules don't dictate this, but you could use a capacitor. A capacitor to get more amps. To get more amps, but not more volts. So you're storing energy, that's really what a capacitor is. You're storing energy to be able to use for later. And that energy source can be then deferred to another power source. Now, I'm not saying you have to use a capacitor, and in its simplest form, you really don't need to use a capacitor, but if you want to be able to up your amps without upping your voltage, in terms of that power equation, that's the easiest way to do it. Someone asked earlier before we got started about resistors. Absolutely. Resistors are great, especially ones where you can actually dial down the fan speed or actually raise the fan speed. And depending on how far down the track you want to go and distance and speed wise, that's important. Okay. And now, going back to the track, one more thing I do want to mention. The beams themselves are 215 centimeters long, which is fairly close to this, without even measuring. There is a cushion barrier. The cushion barrier is not dictated by what the actual cushion barrier is in terms of construction. So what I've seen recently is some type of foam barrier, something lightly wrapped around an actual additional wooden block, something that's basically going to make sure that the car does not go off, or the hovercraft itself does not go off of a table or does not run off into the hallway somewhere like that. So very simple cushion barrier. Don't overthink the process on that end. As far as the wooden block is concerned, there's no specifications other than it's got to fit in the track. So don't think you got to go out and buy any type of specific wood. It needs to be something heavy enough to hold the actual craft from starting. The intent of the actual wooden block is to literally just make sure that you have a time differential. So when the event leader removes that block, they can actually start the clock and have it move it down track. All right. Now, as far as the vehicle is concerned, as I said earlier, 15 to 30 centimeters and cannot exceed 30 centimeters during the run, including inflated skirts. And the vehicles, excluding dowel rod, must be less than 20 centimeters tall with the propeller in motion when non-levitated. So, simple. Base, regardless of what the base is, and I actually have a skirt kind of built in for this one. We're going to measure from the bottom up. Propeller, I'm going to measure from the top of the propeller as much as we can when it's not in motion. Very simple in terms of that. Word to the wise, don't measure your propeller flat. Yes, sir.
How high you said it could be?
It needs to be no taller than 20 centimeters tall. All right. So make sure you measure from the top of the actual propellers, and you can adjust it. I like using styrofoam. I'll go ahead and talk about construction materials just for a second. I like using styrofoam because I can alter things very quickly. I don't have to worry about it. And if you have paper clips or some pins, you can actually change the height and variances as you're trying to model this out and figure it out on your own. Okay. All right, the dowel rod. Let's talk about that real quick. And remember I said the mass, including the battery and the dowel rod, must not be more than 2,000 grams. There is an electronic scale there at the actual competition. But the dowel rod itself needs to be, needs to actually have a 1/4 inch length dowel rod. Like this, okay? It's gotta be a certain height. And the purpose of this is for the photo gate. You know, it's easy to have a hand timer start and go. It's a whole lot easier for us to trip a photo gate when you actually have a mark going through it. So the vertical position of the dowel rod is important so that you can actually get accurate timing. That's generally the way that works out. All right, and it says specifically the vehicle must have a 1/4 inch or larger vertically attached within 5 centimeters of its front edge, such that the top end is between 30 and 35 centimeters above the lowest vehicle surface. Okay, trying to get accurate timing. Now, Paul mentioned earlier, he actually has not just the photo gates, but there's a laser setup that you can be able to do the timing. Many times what you'll see this, and it depends on where your regionals or states, if they don't have a photo gate, they can go back to old school timing of the devices. You need more than one timer to do that. Typically there is a laptop attached to the actual photo gate display or the actual laser setup to make sure that you get accurate readings and that it can actually be recorded into the timesheets. So keep that in mind, keep that in place. Now, as far as the battery is concerned, I did say that we had the different ones that are available. I actually took a trip to a number of stores in North Carolina just to see what I could get back in terms of batteries as well as motors. Let's talk about batteries real quick. I don't know how many Radio Shacks are still left in Michigan. I know there are not a lot in North Carolina. Don't feel bad, okay? It is by far the easiest place you can walk in and get whatever electronic tools you need. But if you have a local hobby shop, you can be able to find some things of that nature as well. A couple of different things that I do want to point out. in terms of the batteries and the battery packs. This is a case for, if I can get it off, I didn't unscrew it, and that's my fault before I got here. This is for 2 AA's, very simple, we'll pass some of these around. This is for 4 AA's, and this is for 4 AA's, okay? Easy. Easy to use. We also have what I call the leads for a 9-volt, but not necessarily. The 4 AA pack that you see floating around will actually have the same connector that you would see on a 9-volt battery. So if you want to be able to use it less volts, more weight, but still have that 9-volt feel, you don't have to worry about the wiring as much, you can use the leads for that as well. Definitely you want to be able to get, I let this young man back here borrow my wiring strips, but you don't have to use particular wiring strips. Most of these are gonna have open leads for them. You can go kind of old school and get some alligator clips. Easy to use, a lot less prone to get yourself in trouble in terms of accidents happening. No cutting your fingers, no electrocuting yourself in terms of the actual battery. Yes, sir.
What are those called?
These are alligator clips. And the reason they're called alligator clips, they're alligator clip wiring, I should say. The reason why they're called alligator clips is if I can actually get them out. I can't get them all the way out. And I'll pass these around. These are cheap. It's because the clip itself looks like an alligator's mouth. Very easy to use, okay? They've got a casing over them to make sure that they don't electrocute you in terms of the battery. Correct. In case the battery overheats or the wiring overheats, it won't melt in your hand. If you've never played with voltage before, don't get creative and start playing with things larger than a 9-volt battery. It can be very dangerous. Stick to regular batteries. Yes, sir. Oh, cool. Just to see.
Both B and C are here.
Oh, okay. Awesome.
How close are we to set?
Oh, we're still a while. Yeah. I'm going to pass out these sign-up sheets. If you're B or C, just fill out the appropriate form. We're good to go. All right. Now, I mentioned earlier about the batteries themselves. One thing I do want to point out from the beginning, and this is a clarification that's come down recently, as in the last month or so. You're supposed to have 2 motors on the device, okay? There's supposed to be 1 motor to inflate the skirt, as you see here, and 1 motor to direct the device, as you see here, okay? Now, here is the catch and the rules. I've been preaching to you for the last 20 minutes about 9-volt batteries and 9 volts not exceeding that much. I'm going to go ahead and tell you for clarification purposes, you can power the 2 batteries with 2 9-volt batteries. Okay? That is to say, each motor cannot exceed 9 volts. Okay? Now, if you want to be fancy and be able to power both motors off of 1 battery source, you can. But I'm going to repeat, you can use each motor not to exceed 9 volts. It does not inherently say that in the rules. This is something that has been clarified by nationals just because of the way the rules were written. Okay? So each motor can have an independent battery source of its own. Yes, sir?
Do I have to sign my partner's name on it?
No, just yours is fine. Yes, sir. Your question? Okay. All right. So, as you can imagine, having each motor have an independent battery source makes things a lot easier in terms of wiring. So keep that in mind as you're going through and looking at this, okay? Fan here, fan here. All right. Granted, we've got to be able to get to the skirt. We'll get to that in construction in a second. All right. The entire vehicle, including propellers, require shielding. must not exceed 19.5 centimeters in width. We are talking about the diameter of your blade, okay? Everybody knows diameters versus just one propeller, okay? We need the entire diameter. Cannot exceed 19.5. Now, I will go ahead and tell you, just from experience of me trying to put one together for you, a small blade is great. You're not gonna get as much lift or action in terms of wind. The larger blades are great. Let me back up. The smaller blades are great, but you're not gonna get as much wind power out of them, okay? You can get more speed, and they're a lot efficient in terms of closed space, like inflating your skirt, but you're not gonna get as much in terms of the actual wind power as a whole. However, the larger blades are greater. You can get a little bit more wind speed out of them, but then they become a pain in terms of being able to figure out how you can inflate the skirt appropriately without cutting into your bag. So you got to play with these. This is a standard blade I got from Radio Shack, okay? The blades are very, very easy to come by these days because of drones. That's the reason why I told you about that example at the beginning. You can get a blade literally from anywhere. Target, Walmart, anywhere, they've got spare blades. Now, if you're gonna be a little bit more, have some new ingenuity to yourselves, I would recommend you go ahead and build your own blade just to see the difference in wind speed on your own, okay? It's not gonna hurt for you to build one simply out of, and I'll take one out for example, get you a styrofoam plate, cut it up, build your blade, make it simple. I saw somebody last week when I was in North Carolina that used corrugated plastic. Doesn't matter. Stick your center mass through the center of it, make sure it can rotate and go accordingly. I mean, I'll even butcher up this plate. Forgot what I do with my other dowel rod, but doesn't matter. Even if you gotta just go ahead and just poke it through, well, I thought it was gonna stay, and build you a blade as simple as that, go for it. It's not gonna hurt. You're gonna find out really quickly what's efficient and what's not whenever you get it wired up. One important thing I will tell you, oh, and you can cut these blades down. These replacement ones that you have, if you gotta cut the tips, that's fine. They're gonna be less aerodynamic if you cut them. Obviously, I necessarily would not use a metal blade, by the way, even though you can in the rules. And there's a reason for that. Don't get your fingers cut. Stick with plastic, your fingers go a long way. All right. One important thing I do want to mention though, in terms of the blades and the power is it's hard to get our motors to attach to the blade because of the hole sizes. These drone blades that you're going to find in the stores have a hole size that's specific for a certain type of screw. That's fine. I would highly advertise and hope that you would use some type of putty or glue guns, or I should say glue stick substance that's going to attach to the blade. I personally use the hot glue gun. I went very old school in this because if you've been around Olympiad a long time, you know Olympiad likes to use epoxies and other special type of glues. Every now and then you got to go to the basics, and if you've been through the elementary division, you definitely know about the basics of using just a regular plain hot glue gun. Use this, attach it to the propeller and to the motor, you'll have no problems. Stays pretty efficient, and the great thing about it is even if the propeller breaks at any certain point or you want to change propellers, it's glue surface that you can actually throw away and amend very easily. All right. Brushless motors and integrated circuits are not permitted, which brings us to our discussion about the motor before we get into the levitation portion. So, if you are the normal Neanderthal man and you believe in having the biggest motor possible, well, I'm here to provide you one. This is the 9-volt super speed hobby motor. This sucker can really go, and I'm not even going to go ahead and hook it up in terms of power. I'll pass this around. This is the biggest one that Radio Shack carries, 9-volt, okay? It can give you plenty of wind speed. I think the amperage on this is actually this does, and please forgive me on this one. This motor actually can be powered by 9, 12, or 18 volts, okay? DC current. And it says 380 milliamps is the max current for the 9-volt one, which is about 11,000 rotations given in a current actual timing construct. So I'm going to pass this around for this battery, or not battery, for this motor. Take a look at that. Now, for me, and knowing that we see all these drones flying around, and I use this example often just because it is the current usage of propellers that most kids are seeing these days. They're not using motors that big, not even close. And there's a reason for that: weight. It's kind of hard to be able, you don't want the motor to tip over. You don't want the motor to rock back. If you had a heavy motor on the backside that you're working with this propeller, you need to change the actual weight composition of the device so that you don't get all your weight in the back, you don't get all your weight in the front, different things of that nature. So of course, naturally, the next question is, well, what other motors are out there? You know, what kind of motors can I get for less voltage? Well, it's funny that you asked that. This is a 6-volt battery. Or excuse me, 6-volt motor, okay? 6-volt motor, and I'll leave this in a pack so that we don't miss the label of them as well, is less than half the size of the 9-volt one I just showed you earlier, okay? I also have a 7.5 volt one, okay? 7.5, a little bit more stronger than the 6-volt. And then if you really want to get a 9-volt battery and you want an efficient motor that still does 9 volts, Radio Shack's got those smaller ones as well. 9-volt motor, but half the size of the large 9-volt motor I sent you. So if you want to get a little bit more efficient motor, they have those available as well. Now, as far as the motors are concerned, I'm going to tell you, even if you don't have the time to go to Radio Shack, but I know many of you in here have some type of battery-powered vehicle or device at home. I should say motor-powered vehicle device at home. You can take a remote control car, strip it down to its components, and be able to get the motor out of that. Okay, this literally, and if I have my PowerPoint up, I'll show you, this literally came out of a Target purchased remote control car that cost $12 off the shelf that I stripped all the way down to the motor, attached a propeller to it, and put it on the back. The reason why I like this one is because I don't have to think about, as a person walking into the store, I'm not thinking about how slow the speed is. Don't even care. I know a remote control car can go, and I like that speed. And I want my wind power to have that kind of speed. So why not use the max one that's in a remote control car? Makes sense. You can figure out the science and stuff later, but when you have an example of something that you know will work, why not use it? It actually uses less than 9 volts to be able to do this. This is about 3.5, with this particular car, it was about 3.5 volts to be able to run. But the good thing about it is, if your motor takes less than the maximum amount of the battery you're using, it'll run run easy with no problems. So, of course, I went ahead and took a 3.5 volt motor and plugged it up to a 9 volt battery. Runs like a charm. Okay?
It doesn't burn up the batteries because it's uses less.
Exactly.
Does the motor get hot?
It depends on and this is depending on how specialized the motor is. So yes, over time the motor is going to burn out, but try not to run it into the ground. That's the kind of rule of thumb on that end. But yes, you can burn out the motor if you're not careful, and the motor can get hot. So with that said, I actually took a remote control car motor here, and then I took a 3.5 volt motor here, okay, in the center. I'm going to go ahead and tell you, I took the skirt off of this earlier, and I may not reattach it later because I had to actually glue it back together for you. But I had this on earlier this morning. It is hard to inflate something in low voltage. I'll leave you with that premise. Very hard to inflate. You want as many revolutions per second within reason to inflate something in terms of a skirt. So keep that in mind. But both of these actually do work, and I can plug them up and show you here. And for oversimplification demonstration purposes, 9 volt battery and alligator clips. I didn't have to. If I was at home in my home shop, I would easily use a soldering kit, just hardwire them in, no big deal. But I want to be able to show you all the differences of this and how it all works out. All right. Very easy. I can go and tell you in terms of construction, this is literally the motor. I put a hole into the styrofoam. You can see the hole here. And then I took styrofoam plate and hot glued it to the front end of the motor, to the actual axle, and then hot glued the actual propeller on there. It's not bad. This will not count as a skirt, and we'll get to the skirt conversation in a second, but it does serve the purpose of being able to have a motor at the bottom. All right, now, as far as my let's see here. As far as my other motor is concerned, remember I told you about that race car? That remote control power race car? That sucker's strong. You know why? Actually, let me bring this to the front so you can see a little bit. Because it's going to move on its own regardless. And I can't get as much of it here. I'll try to put it on the stool so you can see. I don't even need a skirt for it to move. It's going to move on its own because the actual motor is that strong. And I'm losing power here because my alligator clips are coming apart. Okay. Now, this brings up a good discussion about a couple of different items here that I just explained. The first thing is, again, you can use stuff that you have at home, strip it down and be able to use it. It's going to be powerful enough, I promise you. This device can solely be powered on a track by the top motor. But the rules say you got to have two. Okay. And the rules say that you have to have a skirt intact. And the rules state that you have to have that skirt be able to be inflatable with the generic description of the judge should be able to press down on the device to see if it's inflated or not. Okay. Obviously, no plastic bag, no skirt. Does not count. You don't get points for it. You've got to have it to have the ability to inflate it. Now, you can be able to inflate this in a couple different ways. Had I had a little bit more time to get set up here, I would have pulled out my gallon storage bag that I would have purchased, like a gallon freezer bag, placed it in my actual skirt, had a whole opening around it so that my blade propeller could go around it, and then I've got something to inflate me and move me down the track. Okay. Now, after testing this and knowing the type of materials I use, and I purposely try to use as cheapest materials as possible, I know that it was very hard for my bag to inflate with the 3.5 volt motor. Okay, so I would have probably used a much larger powered motor to make sure that my bag inflates. The other problem that you're going to find out and see in terms of construction, and this is key when you understand this, filling up an actual bag is simple. Everybody's filled up a balloon before. And for oversimplification purposes, I'm going to try to fill up this plastic bag. All right. Real easy to fill up a plastic bag, even though this one has holes in it. If I had a propeller around it, I could probably fill this up and still make it look like it's a balloon shape, right? Whole lot harder to make it have its contours and stabilize it when it's actually pointed downward and the fan's going so that the bag is spitting out. Therefore, you need to have some height variance, something that's going to give you a little bit of give so that your propeller does not chew up your bag. Okay. So I added my edges in terms of the skirt. These edges are completely oversimplified in terms of use, but I'm trying to give myself enough surface area to be able to inflate the actual bag itself. Okay. Again, you got to be able to have some give on that in terms of know that the bag inflated. But the other part of it is you need to be able to get that blade breathing room to be able to do the inflation itself. There's nothing worse than wiring all this stuff up and either having your blade pop off after you've already glued it in and wrapped your entire skirt around, or you've torn a bag and you got to be able to figure it out. Now, and the variances that I've seen of this from different students, like we have the ones that these folks are building today, is that you're going to skirt, you got to be able to experiment with your skirt. I've seen skirts with holes in them, multi-holes, one center hole, no holes. It's completely seamless in terms of that, other than to be able to have a propeller in there. Completely up to you and how you want to use it, okay? Use the bag however you want to make it. You're going to know the efficiency of that bag and whatever construct you want. Me personally, I've tried the actual plastic bag like this. I even tried a garbage bag. I like the thicker bags because I know that my blade, if it's plastic, will not necessarily cut the bag itself. So I like freezer bags. I like storage bags. The difference in terms of the surface area is there's less give for a thicker bag than it is a thinner bag. Very easy to inflate this bag, but its wear and tear may go down very quickly compared to a thicker bag. So play with the different portions of that to figure out what bag you want to use. Yes, sir.
Is that we need one motor? Do we have to have 2 motors?
Yes. He asked, do we have to have 2 motors? And the rules specifically state you've got to have the ability to inflate the bottom portion. Now, if you want to be able to have it so that, like you was doing right there, you can do it that way. But then the question is this going to help you guide down the track? Because you've got to be able to move forward. And then that's the reason why they're telling you to use 2 motors.
It says no more than 2, but you must have 2?
Yeah, no, I'm sorry. I'm saying that incorrectly. You can have 1 motor to power the entire thing. You cannot have more than 2. If he wants to use his wind dam that he set up on his, he can. But what I was telling him was he's got to figure out the efficiency of the wind power to move down the track. Okay? All right. One important thing. I've showed you a lot of battery power. What I haven't showed you in the rules is very, very specific. You've got to have an on-off switch. Okay? Got to have an on-off switch. Construction set of rules, 4K vehicles must have an electric switch to permit safe starting. A stopping system to stop vehicle motion or shut off motor is recommended. So, of course, I brought you all, if I don't fall over here from the cart moving, I brought you all some switches to look at. A very, very, very tiny switches here. This is called a slide switch. Be careful, this bag has a little hole in it. So if you want the smallest switch possible to be able to count, you can use that. My personal favorite is the idiot-proof one. It's got an on and off properly labeled. I'm not gonna screw that up, okay? I love old school switches. This is a great one, so I'll pass that around. Who's got the battery pack?
Over here.
Awesome.
Everything's here.
The 4, guess what? You all went through the entire classroom
They wired it all up.
and showed the, thank you.
Yep, I know.
Oh, you can keep all this.
Here, I'll bring it up.
This particular wire battery pack, the 4-prong one, or the 4 AA one, went through the entire classroom. Did anybody notice it had a switch on the back?
Yeah, I did.
Okay. So, in order to you having to avoid buying a separate switch, you can also buy the battery pack that has a switch attached to it. Serves dual purposes. Okay. Keep that in mind in terms of efficiency. Me personally, I just like the fact that I have a switch that I can use, so I'm going to use it. I want the old school on and off switch, something that's going to toggle. Yes, sir.
Does it need a auto shut off, or do we switch it?
No, you do not have to auto shut off at the end of the run. It can be manual shut off at all times. If you want to do auto shut off and you can be that efficient in terms of your building, go for it. But you don't have to.
Question, on the 9-volt battery holders that have a switch that connect to the boxes, can you use those boxes even though your 9-volt battery's not showing?
Yes, with 2 things that you want to keep in mind. One, the event leader wants to be able to see what that box is. So they need to be able to,
The box has got to be available.
yes. So for 2 things. One, we need to make sure there's no integrated circuits in there. And then 2, we need to be able to see that it is a true 9-volt battery.
So they will take it off and look at it and put it back in.
Yeah, and it could be before or after.
So I mean, if it's closed, they're not going to say, "Why I can't see it."
Correct. So what normally happens with this in terms of event leaders is you can go ahead and run the device without us touching anything to do the inspection. And then after the run, we could be able to see it. The only catch to that is you typically weigh your device without the battery. If I'm not mistaken, let me make sure I read that correctly. Yeah, mass of the vehicle, I'm sorry, including battery and dial must not exceed 2,000 grams. So I said that wrong in inverse. Yes, so you can put the battery in there, and then after the device runs, we can take it out.
So we have a device, I want it to go slower, these guys, they add weight to it.
That is
You can reweigh it.
yes, that is a very good question. So there's a couple different options in terms of speed variances, and we can talk about that now since we brought it up. So everybody, he wants to know, can we change the mass of the device in order to be able to change the speed of the device? The answer is yes. There's a couple different ways you can change speed variances. The first one is a simple one, mass. Adding more mass to the car is going to slow it down based on whatever standard motor you have, okay? So if you want to be able to change, you have a calculation in a spreadsheet that you've already talked with the student itself, and they say, all right, if I have 5 kilo here, it's going to give me a certain speed down the track. Perfect. The other one would also be wind variance. Okay. One thing I did not display that I'll show to you now is when building your device. It's a couple different things here. One is, this is pretty poor design work in terms of wind efficiency, if you really think about it, because the wind current is coming through. I mean, if you ever stood by a fan, I think we've all done this as a child. You get behind the fan itself and the wind's blowing in this direction, and you start yelling into the fan, and it makes that weird noise with your with the actual sound of your voice. It's because the wind current is going through the fan and doing something odd to it. It's changing the actual track of it. The same thing is true if you actually change the post behind the fan itself. I've got a lot of the posts on the bottom half of the fan closed, okay? That means I'm changing the wind action behind the fan. I want to be able to do something different with that. So the skinnier the post, the less wind resistance that you're going to have with the wind coming in, going in another direction.
You mean that red thing that the propeller's attached to?
Yes.
Okay.
Okay? Because the wind for this one is being drawn in this direction. Okay? It's going out because we're trying to move the car down the track going this way. So it's got to draw wind coming out from the backside. Okay? So the skinnier the post, the better. However, if you're not using any type of metal soldering, you've got to have some type of device or clamp that is going to clamp the motor to the post. Okay, so in purposes of this, there's a post here that I'm using for the actual motor itself. Many diagrams that you'll see online, it is a curve post so that the curve starts at the bottom and curves up, and then you can attach the motor to the top of it. Okay, I tried to use something very simple in terms of the styrofoam so I didn't have to worry about it. But if you want to use some type of plastic, or what the first thing that came to mind for me is some type of handle that has a slight curve to it, you can kind of screw it to the base, glue it, and have a curve so that your motor can sit on top. Now, we talked about wind variance on that end. The third thing you can do to change the speed of the device is to use a different motor. So, if you've got a way to clamp the motor to the post itself, then all you gotta do is remove the clamp, drop another motor in there, clamp it back down, and then let the car fly. Okay. It's not often that you're going to have such a speed difference and variance that you'll need another motor, but if you really want to be efficient in how you build your device, you can. One more thing that I forgot to mention in terms of the wind variance. Wind power can be altered in terms of actual guards and funnels. Okay. So for very, very simple purposes here, I have been able to put up an actual wind guard, and it does help some. And granted, this is the cheapest construction possible for the wind guard itself. But you can just tell from it moving around the cup itself, it is changing the wind direction. It's giving a little bit more lift. I can tell you that having some type of wind funnel or propeller guard is going to help in terms of steering the device. I highly recommend you use one. If you see the different diagrams that you'll see in the PowerPoint later, or you see them online, they're going to have some type of wind guard there. Okay, similar to a traditional hovercraft, when you see the actual blades of the fan and it's got some directions there, there's an actual steering mechanism that normally guides the thing and is able to change the wind direction. It's the same reason why they have this guard to be able to have the wind around there. Okay. Now, you don't have to be super fancy in building these out. I literally cut inserts into the side of my styrofoam plate that I use and an open cup. These cups were like $2 from Walmart. Okay. You can use solo cups. You can use whatever you like. You don't have to have anything fancy. Obviously, and for even more simplification purposes, this cup is smaller. The circumference of the cup is smaller than the blade. okay? That blade is not gonna be able to move around because it's all in the center of the cup. So obviously I had to make it a little bit larger. So even though I had a thicker post to be able to measure this on, it actually helped me out later when I had to put in the actual wind guard there. Okay, these are small things you have to think about as you test your device. Now, another thing that I've seen is kind of a hexagon shape to some of these guards, or even an octagon shape if you really want to go out. So instead of having this round, some people are actually building out an actual hexagon or octagon on top of the actual device, give it a permanent guard, and then that way you can just change out your fans however you want to, or change out your motors however you want to. It's completely up to you on how efficient you want to be, but you don't have to. The part of that in terms of building it out as around the actual motor and fan is because it allows you to have a skinnier post to hold the motor in place. Okay, you can do a vertical post, you can actually do an L post, but at some point in time, you're going to have that post be as skinny as possible so that you can get more wind going out in the other direction. Now, before we get into some of the actual competitions and how everything is going to run, I do want to talk about kits for a second. Ward Science is pretty much the unofficial kit provider for Science Olympiad nationally. They have some awesome kits for every event under the sun. They're expensive. Not saying they're not the best. They will guarantee that you will be able to have a great placement in your actual competition within reason. If you are automatically assuming that their speed variances will be better than the competition, but you're doing a lot of assumptions that way, okay? So let me say this in a very simplified way. Do you want participation points in your event? Get your Ward Science kit. Get you some other kit that's already pre-made online. If you want to win, build it your own way, do it yourself, and make changes accordingly. Not to say that you can't make changes with the kit, but it's a lot easier to know the science behind something when you build it yourself. All right, with that said, Radio Shack actually offers, and you'll see this in a couple different stores, what they call the kind of STEM learning kits in terms of batteries and constructions. There's a robotics gear motor kit, okay? And I'm gonna pass this box around so you can see it. It actually still has all those parts in there, minus the wheels I took out. There are 6 motors in this kit. There's 2 high speeds, 2 mediums, 2 lows. There's 2 motor plates that we're not using for this. There's 2 wheels that I took out, and it comes with the battery compartment cover with the screw. The screw with the switch I showed you, this one came from this kit. Or is that screw with the switch? The battery pack with the switch came from this kit. Now, 2 high speeds, 2 mediums, and 2 lows. I went ahead and glued a propeller to this particular device so that you can see it. So this is the motor, but see there's an axle here. So automatically you can tell, well, this is great. It's a robotics kit, but my propeller is not, it's perpendicular to my motor and not vertical, or it's along the same plane as the motor. So now I got to put my motor like this and have the propeller out here. That's kind of weird. I don't know if I like that or not. All right, sure, you can unscrew this and change the configurations, but again, you've already got something that you inherently were not expecting to see when you open the box. The other part of it is, and I'll break this apart real quick. You don't know the speed of this motor like you would do for a race car that you have at home. Remember, I really like the idea about the race car because I know it's fast. It's gonna go and give me zoom. But as I'm looking at this box and I'm in the store and I'm like, man, this thing says high speed, low torque, and it's only 200 milliamps. I'm like, I don't know. I can't do the conversion in my head to figure out the speed, and I need to be able to test this out in the store to see what kind of speed I'm gonna get on my propeller. Well, lo and behold, after I got this home and looked at it, and you can tell a huge difference in this as soon as I start it up. If I can connect it real quick. Mind you, this is the high speed one.
Oh boy.
Not very high speed. Not even close. Okay. Again, it's a kit, and I can go and tell you, this kit was $20. Okay. $20 for this kit minus the propeller. I'll put it back in the box for you. I like the fact that it had the battery pack with a switch, but I could have bought that for $4 at Radio Shack. Okay, so be leery of the kits that you buy off the shelf, but also be leery of kits in general, because more than likely you can find a better solution already at home for what you have, and have something that's going to be the ingenuity that you need without having to take it home and figuring out whether it's going to work or not. Yeah, give me like 10 minutes and we'll go. I gotta figure out the table. I'll probably use the table here as well. Yeah, we can go and get set up for at least one. Grab a table here. Yeah. There you go. All right, Paul's gonna help us set up a track real quick. We can test a couple of these out. While we're working on that, let's talk about a couple different things in terms of the vehicle testing. Go ahead. I knew there was something in there. There you go. All right, the competition portion is very easy to understand, so we're gonna zoom through some of this stuff. We talk about the length of the time portion of the track. There's a length of time that has to be decided. It's 100 to 195 centimeters in Division C, and 130, give or take a half centimeter, in Division B. Okay, so for all of our middle school folks, 130 is the distance down the track. No questions asked. Don't have to think about it anymore. You're good to go. Test everything off of 130. Okay, for our high school students, it's literally going to be 100 to 195 centimeters. I can guarantee you it will never be either 100 or 195 centimeters at states or nationals. So guess what? You need to be able to plan for that middle distance. Don't assume 100. Don't assume the minimum or the maximum. Don't assume 100. Don't assume 195. You need to be able to get it down the track accordingly. Okay. The event supervisor is going to check the vehicle specifications during impound, right before a team's testing period begins, and the teams must be notified as soon as possible if a vehicle does not meet the specifications. Let's go over those specifications real quick. And the reason why I read that, because this is where people fail every single regionals that I've ever been to across the country. Okay. Number one, is your device in the actual measurements specifications as listed in the rules? I'm going to measure the length, the width, and the height of the device to make sure that you are able to run. I'm going to test the battery and all power sources to make sure you don't exceed 9 volts per motor source, okay? Or per motor, I should say. So you cannot exceed 9 volts per motor. Say that again, you can't exceed 9 volts per motor, okay? So I'm going to test all that. I'm going to measure your propeller. I'm going to check your skirt to see if it inflates. I'm going to check if you've got 2 motors, where they are, and if they're all working properly, okay? I don't care the materials that you're using other than you cannot have an integrated circuit, okay? These are baseline things that you got to check on your vehicle. Then we want to make sure it fits down the ramp. So I'm going to measure it on the track as well. Even though I've already measured it here, I need to make sure there's nothing else crazy, okay? One thing I did not mention, in terms of building out your skirt, you could change the skirt. The skirt doesn't have to be rectangle. I've seen people use rubber hosing around the skirt. I've seen folks try to give certain kind of disc around there. The skirt really, when I say disc, I'm talking about an actual sliced edge, almost like a CD disc, to kind of give it less friction along the side of it, okay? You can use whatever you want for the skirt within reason. The rules don't give a whole lot of variances in terms of the skirt construction, other than the fact that it has to be an inflated skirt. If you don't want to use an actual material around the skirt, you don't have to. It's just an aiding tool to get down the track, okay? What you don't want to happen is the friction, and many of you may not have studied the coefficient of friction in terms of the equation, but you don't want to have it where you get stuck because your device does not have the actual reducing of friction down the track and gets into one of the corners. So think logically on this, and think so that if something does get stuck, do you have enough power to kind of move it down the track even regardless of that? It's often not likely you'll be able to travel from A to B in a straight path. That's what we all hope for. But it's not likely just because of the type of materials we're using. All right, 3, 2, 1 launch as normal. Same thing with scrambler car. Same thing with any type of wheeled vehicle device if we've ever run in Olympiad. 3, 2, 1 launch, 3, 2, 1 start, 3, 2, 1 go. It's all the same. If they have manual timers, the event leader needs to tell you they're using manual timers. If they have a photo gate or some type of laser timing device, they need to be able to tell you that as well. Something has to be an indication of how they're being able to measure everything. Now, if a failed run occurs, if a vehicle does not meet construction specifications when timing for that run starts, fails to move for 3 seconds at any time, fails to cross the finish line within triple the target time, or any part of the vehicle falls off. After a failed run, the team must be allowed to repair and restart the vehicle if the time remains in the 8-minute period for a maximum of 5 failed runs. Well, a lot in there, a lot to conceptualize. You get 5 runs in 8 minutes. Doesn't matter how you run them. You can make whatever adjustments you need within reason to the actual device. Yes, sir? Oh, okay.
So, but if you have 2 successful runs, you're done.
Yes, that is correct. You only need 2 runs to be successful. Once you have a successful run, you're done. Now, you could technically run another time for a better time to see if you get a better time in terms of distance down the track.
Okay, that was my question. In 8 minutes, if you can have 5 successful runs, you take your best of the 5?
You're gonna pick your last successful run is what it should be. When I know that's
if you take an additional run, you're disqualifying your previous run.
previous lowest run,
Previous most successful run, is that?
least successful run is the way it's supposed to be. Now, this is a clarification that has not come down from on high as to how they're going to toss out successful runs. But I can tell you from previous experience and other events, it's supposed to be the 2 best runs overall. Okay.
Earlier you said that we could have 2 9 volts powering both motors.
You could have 1 9-volt per motor.
So if you have 1 motor, that means you can only have 9-volt battery on it.
Correct. Each motor cannot exceed 9 volts.
But you could run 9 volts in, let's get it back, parallel,
Yes.
and have multiple 9 volts to
Yes.
powering a single motor, as long as the voltage across any 2 terminals is no more than 9 volts.
Correct.
Okay.
That is the correct way to describe that. Yes.
Earlier you said the heaviest and the fastest car wins, so you want it to be heavier?
You do want the car to be heavy, but there's something that you're going to have to figure out on your own, which is how much heavy the car can be to make it the fastest out of the track. And there's a point of no return in terms of which part of that equation is going to work.
You're not making it fastest on the track. You're making it closest to the time.
All right, I'm sorry, closest to the time. Most efficient is the proper term. So
What's the heaviest you've seen? Yeah, successful.
for
The heaviest successful one you've seen.
I mean, for this year's rules, I saw one last week that was like 400 grams. Yeah. And, I mean, it doesn't seem like it's that heavy, but this kid used a paint bucket, a sand bucket, like a child sand bucket, and made his propellers. Granted, his motor was like one of the big ones. It's a 9-volt one, so he was just going for it, trying to churn out as much wind power as possible. But I mean, he even admitted his battery burns out quick whenever he's testing. He's running through 9 volts back and forth. It's very hard just to kind of get that out. I haven't run that many for this year's rules yet, so I haven't seen enough. I will give you my email address at the end. I know that we're running our first and second largest tournament in North Carolina in 2 weeks, and I can tell you a whole lot more then in terms of that.
Just to make sure I'm clear on the battery, I have an 8.4. You have 8.4. You can overcharge it. What is measured?
Voltage. He says he has an 8.4 battery source and he wants to overcharge the entire source of the actual device. What is being measured by the judges? The judges are only measuring voltage. We're not measuring amps. We're only measuring
They're
voltage.
not going based on what's labeled on the battery.
No.
I thought I read it.
No,
RC car batteries can overcharge and they wouldn't.
correct.
That's what it is.
Now, what the judges will do with what's labeled on the battery is it does not exceed 9 volts as labeled. And the voltmeter being used shows that it does not exceed 9 volts.
Because there's a lot of 1.5s are actually 1.6.
Yeah,
You're going to be over.
correct. Correct. So,
So if I have a 9-volt battery that they go to test it, it comes out as 9.1 volts, I am illegal.
correct. So you can up your amps, you can't up the volts. Okay. Now I saw a couple before we get any further on a power discussion. I saw a couple what I call commercial fans being used. Absolutely incentivize you to use as much commercial fan looking devices as possible. What is the hardest thing to do is you walk into a Lowe's or Home Depot and you're like, man, I really want to use one of those appliance fans that I've seen and whatever appliance. Wouldn't that be awesome to be able to just use a fan that's already been made up so I don't have to worry about constructing one? The answer is yes. Again, I told you I have a background in computer science. The first thing I thought about was I just use a computer fan out of an old desktop. This is easy. Pull the motor out and be done. The problem is you don't realize that standard operating fan that you've been used to looking at forever and a day runs off 120 volts. Okay, so it's hard to find the fan that's going to run off of a small battery pack unless you build it yourself or you have something that already exists as a fan in a small battery pack. All right, so keep that in mind. Of course, you can strip down the wiring to nothing and just be able to run it, depending on what the motor looks like, or you can just borrow the fan off the actual traditional fans that you see in the different appliances, steal the actual fan and the axle, and then attach it to another motor so you can use it there. All right. Now, scoring. We've talked about this in a couple of different ways. I'm going to go over the scoring one more time. Mass score equals mass of the vehicle. It's the mass of the heaviest successful vehicle of all teams times 25 points. The time score is run time minus target time divided by run time times 25 points minus 1. And I said the equation backwards on purpose for the absolute value of score. So essentially it is a efficiency timing score. It is 1 minus the absolute, so that we don't have a negative score, of runtime minus target time divided by runtime times 25 points. The mass of the vehicle must be multiplied by 0.7 when calculating the mass score if any construction violations are corrected during the Part 2 testing period or if the team misses impound. Why is that the case? This is always a question people ask later down the line after they've been to the competition. I got penalized. I don't understand why I got penalized. And how come there's not a different tier system, XYZ? Olympiad as a whole is trying to get rid of tier systems. They want to penalize you for not following instructions. Okay? And the way to penalize people efficiently is to give you a massive point deduction accordingly. So we don't have to worry about getting into tier systems this year. You're going to get penalized by points or you're not. Okay, and that's actually being changed across all spectrums of all events as much as possible. We're trying not to put people in tiers.
I don't follow what you just said.
Traditionally, in normal building or construction events, we have people in tiers. So let's say you're building a bridge and your bridge is too long. Well, the bridge goes into tier 2.
Okay.
Yeah. Compared to people who follow instructions in tier 1. Yep. The problem with that in terms of we may be incentivizing bad designs. They say, you know, all but your child followed directions, but everybody else in here did not follow directions, but we have some awesome devices on that end. We're giving him a lot of credit for following directions, but it doesn't mean he had the best device.
Right.
So we're trying to get people incentivized for, even if you screwed up something along the way, let's see if we can get you to figure out where you can be in middle ground if you just penalize by points. All right. So, and the exam portion that we mentioned very briefly at the beginning, this is a 2-part event. There's an exam portion, and then there's the actual device running portion. Typically, what will happen is that you'll do the exam first, and then run the device second. In the event that you have multiple event leaders, let's say Paul and I are both event leaders, and we can be able to sync things accordingly, we may actually have you run the device first in Paul's room, and you can come over here in my room and take the actual test. It just depends on how much room is available for the actual event to be ran. So don't assume that the test is always first. It may be an efficiency thing, or we've got to be able to run stuff down the actual route.
You might see the option where they take the test in the morning.
Yeah.
Like at 7 o'clock, let's say you have to take the test, and you're given, maybe an hour to do that. Because that technically, even though they say minimum 20 minutes, it's part of that whole hour, right? They try to do it. So there's two different ways that it could be thought about. If Hovercraft's done as a self-schedule, where you would, sign up, self-schedule at that time and do it, then you're probably looking at the test being done at one time somewhere. So let's say 7:30 to 8:30. We've been toying with that, both things. I'm not sure how invitationals are doing it, but I think I just got the last one. I think they're going to do that test at one time and then self-schedule the other thing, which means you just got to pay attention to that.
Yeah.
You know what I mean? Or what it'll be is maybe you'll have 10 schools. I don't know, what is it? It's 5 minutes, right? No, it's
8 minutes.
8 minutes, so say 4, 5, 6, maybe say 6 schools can be done in 1 hour. So then what'll happen is it'll go, okay, first school up, do your 8 minutes, then go take the test. Next school, you already had that first 8 minutes to start, you kind of get interrupted. It's done both ways. But 8 minutes, my guess is a lot of those will be, like I said, test one time. And all it says is minimum 20 minutes. So it could be 40 or, it's just, it all depends really, sorry.
No worries, no worries.
I think we're kind of set up.
That part is important. All right, so I've gone through the entire event. We talked about the rules. We talked about the different parts. Now I'm gonna tell you how to win, okay? Things to think about how you can win. And this is the important stuff. We've talked about the building blocks of this, but I'm gonna break it down even more easier terms for you to focus on. The first 2 things you need to be figuring out when you build your device. What is your skirt and what is your motor that is driving the vehicle down the track, okay? You need to be figuring out skirt efficiencies and your motor that is going to drive the vehicle down the track, okay? This is a bad skirt, it's a terrible skirt. It's great for simplicity purposes of today's discussion. This is not the most efficient skirt possible. This is the easiest skirt to construct, okay? One reason I did that is because I had to get on the plane with all these devices and batteries and stuff. TSA definitely has me on their list. This is not the first time I've gotten on the plane with ball bearings and wirings, okay? So you can be a lot more efficient being able to build stuff at home and not having to get on an airplane for it. All right, so keep that in mind. So
That counts as a skirt?
this does count in the skirt with the bag included. I would have, yeah. Yeah, I actually stripped the bag off. You can see some of the pieces on the side here. I stripped the bag down so you could be able to see the other motor. But yes, this is a terrible skirt for a lot of reasons. One is that styrofoam's porous. It's not going to be able to condense it. I actually had a bag that I ended up placing and building out a frame for the opening of the bag so that the blade would not shift the bag around. And I gave this a guide along the edges so that my bag could stay in place. The edges are great. I could probably go thinner edges. And in fact, I enjoy balsa wood so much, I actually bought a box of balsa wood or a bag of balsa wood so I could be able to make different edges if I needed to. And people can play around with that. So I'm a huge balsa wood fan just because of so many towers and bridges and all kinds of other stuff. It's light and weight and it's very easy to use. Popsicle sticks are fine. Something that's a thin kind of precursor to this. So if you want to use that, you go for it for balsa wood. So this skirt wasn't necessarily the best design in terms of it. It's great for going down the track though. And without having to rewire everything. I'm gonna get down the track, I'm gonna stay in the track, and I don't have to worry about quite as much friction. The question is my bag durable enough to inflate? Okay. The other part of it is I've already put this motor in. I know this motor is too weak and I did that on purpose for demonstration purposes. If I had it already wired up, I need to actually replace this motor because this is a 3.5 volt motor with one of the higher voltage ones, preferably a 7 or a 9, because I need that much wind speed to inflate the bag that I was going to use for this skirt. Again, you'll never know all of this stuff until you do what? Test the skirt with the actual motor and fan, along with the fan that's going to drive the car down the track. Okay. Now, say this in a different set of terms. Your friction is going to be less with a more inflated skirt, but you don't know if the weight distribution is going to be different unless you know what's driving the fan down. Okay. Now, Separate from that, I actually like a thinner top layer that connected to the fan powering the device with the actual skirt itself. I like a thinner layer because I feel like it gives you better direction in terms of being able to propel forward. However, a thicker layer allows for better weight distribution, okay? I can literally load up the weight on this and it not be a huge variance as to where I put the weight at within a reason. Of course, if I put all my weight on the front end, the very front end, it's going to slow the car down in terms of where the inflation point is. But I have a lot more play with this being a little thicker and a lot more solid by figuring that portion out. This is where you're gonna really separate those who are participating versus those who are winning. It's trying to figure out how you can change the speed of the car going down the track based on the distance it needs to travel and carry, okay? Again, we talked about the 3 different ways to be able to change speed, efficiency of the actual fan running for the motor, and trying to figure out how much wind resistance is there, whether we need to increase the actual wind cone, or what I call the wind guard, and changing out the motor if you want to increase being able to have motor size, okay? So keep that in mind on that in terms of being able to figure that portion out. Last but not least, materials. I use a lot of styrofoam. It was easy to put on a plane. I had to get everything in there. I've seen people start trying to use Mylar balloons. I've seen saran wrap. I've seen, what else? Different types of bags that they can use. Somebody had a different type of styrofoam, almost like insulation styrofoam versus stuff that you find in an actual empty box. It's completely up to you. I've seen cardboard as well. Somebody use a cardboard base, okay? You can use whatever materials you have. Let's see, who's got one of this? There we go. Hey, looks like he's got the styrofoam from insulation. He's got the actual commercial size fan guard here. Don't want to mess up too much.
Take the whole.
Yeah, he's got a hole in the bottom of his. There we go. And then a very thick bag, just like I mentioned earlier. This is actually thicker than a freezer bag, but he's got a hole in the bottom of it. There's a bag there. He's got one fan that's going to power it forward. Hopefully that's going to give him enough lift to get down the track. And it's cut in a way where it's kind of rounded on the outside in terms of the bottom of it, but it's good. This is a very good design. And he's using what? It looks like a, what battery? What kind of batteries you got? 2 AA's?
No.
Oh, no. Ah, these are the rechargeable 3.7 volt batteries. This is awesome.
What is it?
3.7 rechargeables. So, I'll get this back to you some of it.
The amps.
Yeah, the amps are the killer part here because it's 5,800 milliamps. Remember the small battery I had? Who's got batteries there? There we go. His batteries look like AA's. This battery looks like a stick of bazooka bubble gum. This is the same voltage for both batteries. Believe it or not, okay? Same voltage. He's got more amps. This is 5,800 milliamps. This is 380 milliamps, okay? Remember, I said you can't increase the voltage, but you can increase the amps. It makes a world of difference in terms of the power, okay? Think of basic physics in terms of understanding how the power equation works. So, same voltage, completely different amperage. The last thing to figure out how to win, and I can't express this enough because I often tell people this, test, 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 and retest, and test some more. Students, you should have a spreadsheet of just test time, easily done. You should also always bring backup batteries. I cannot express that enough. And if I were you, I'd probably bring backup batteries in as many possible sources as possible. He's got some rechargeables that he's using, just as a almost backup, like super backup. Let's say his rechargeables die, he can't find his recharging pack. I would even go back down to having a 9-volt backup. Have something that you know is guaranteed to work, that's just never gonna fail. It may change your weight distribution, but just know that you got this in your back pocket at all times. You don't want to get a competition to have an actual battery that's dead for whatever reason. Very famous story come from a completely different event. I had a device catch on fire 1 year when I was a student and got disqualified, even though it was the best running device possible. So safety is always key, but plan for disaster. It's even better. Okay. Oh, I didn't pass the switch around. This is another switch as well. Don't forget your switches. This is very important. Find one. The easiest way to do this is to find a battery pack that has a switch on it, but you will definitely want to have a switch to be able to turn the device on and off. Are there any questions? Anybody have any comments on material, sizing?
I came in late. Is the sizing all measured when the bag's deflated or inflated?
Good question. Both. We have to measure without the deflation at the beginning. And then the rules specifically state that even if the bag is inflated, it shouldn't exceed a certain height. The hard part for that is trying to figure out, if, depending on how you wired it, what that actual height is if it's moving. So somebody's got to move with it and measure. We'll try to eyeball test as much as possible. If we had a 3D measure, it'd be a different story. So keep that in mind. We'll know within a good range. Most event leaders are going to know, like, oh, if this person's got a balloon at the bottom of it, it's going to expand a whole lot bigger than just a little bit of expansion. Any other questions? Anybody want to test theirs? Anybody want to keep building? Keep building? All right, no worries. I'll wire mine up a little bit here in a second, see if I can put a skirt on it and see if we can get down the track. But
Are we trying to set another track up?
yeah, well, no, one is fine. One is fine because we don't have that many devices.
I think, like, I don't know how to do math with
Yeah.
clamps. There's 4 clamps per track.
Yeah.
Not 2.
Yes, correct.
So I'm 6.
Hilarious. Yeah, absolutely. Here,
Thanks.
no problem.
Just wear
Yeah, no. Oh, one other thing I forgot to tell you. One more thing I forgot to tell you. When wiring, depending on the type of motor you have, and this is important, if you haven't tried to wire any of your motors together, there is an easy way to realize whether you're running clockwise or counterclockwise. You always want the wind blowing to your face. I know that sounds silly. If you hold the actual motor up and the wind's not blowing in your face, the motor's going in the opposite direction. It means it's going to suck the air and go in the opposite direction that the motor's set up that way. Normally you can cross the wires and get it to go in the opposite direction, okay? But you want to make sure you have the rotation, making sure the wind is always blowing in your face. Because if it doesn't and you screw up your wiring, more than likely your device is not going anywhere, okay? That is a very important rule of thumb. So make sure when you wire up your motors, the wind is blowing in your face.
So we're allowed to use like computer fans and stuff, right?
Yeah, the only problem with this is, and it should tell you on here, this is a 12-volt fan.
Yeah, no, but we put a 9-volt.
Oh, you put a 9-volt? Okay, then you're good, yes.
And then, so when you talk about the skirt, you could like take this and like cover the whole bottom and then like put the fan in it. Just...
Correct. You don't have to cover the whole bottom. It just needs to be able to prove that it has some inflation.
Okay, but would that work, do you think?
Yes, I have seen it. His skirt actually has a hole in it. If I put a bag over it, it will work.
But I want to see the skirt.
Oh, sorry.
Right now, the skirt seems like it's the very critical portion.
Yeah, I would have to go back and tape the bag back over it because I brought an extra bag on that end.
What's the mass of that?
I actually don't know because I have not weighed this one.
That whole thing's probably about 250, 300.
It's not a lot. Not a lot at all. And I've got 2 battery. I had it set up so I can either use 1 or 2 battery sources because both of these are less than, both motors can run with less than 9 volts. And then I have a switch separate from that. I should have my other switch in there, but I've wired up both switches for it all to work out, integrated circuit wise. What you need?
The case for the 2 double A
Yeah.
batteries?
Check that one right there. You got a screwdriver back there? You have to screw out. Take that screw out.
Aye.
Okay, then yeah, go ahead and borrow this one.
Do you have any experience with these?
I have seen these run in a couple different devices from a couple years ago. They're fine. The only problem is normally it's just the weight of the motor.